Hello everyone, welcome to my YouTube channel. Thank you so much for your amazing response, valuable comments and feedback. You all know we started this podcast journey to discuss about health, education and lifestyle. As a part of this series of podcasts, today we are going to discuss about one of the most discussed technology, that is all about quantum computing. You all know that nowadays people are much talking about quantum computing, but there are so many doubts in the young minds. Those who are joining in the BTech quantum computing specialization, those who are trying to pursue MTech as a quantum computing specialization, and who are doing PhD as a research area, they all have doubts in their mind. Some of them asked me as well, what kind of job opportunities are we going to get? You all know, at the end of the day, whatever we do, we try to be successful in career. As of now, we all are aware that artificial intelligence, cyber security, and other important technologies are there. But what is the essence of quantum computing? How it will be in the near future? What will be the coming 10 years with respect to quantum computing? To discuss all these things, we have a young and dynamic, I can say, quantum visionary, who is nothing but Darshan Kumar, who started his PhD in the MIT in the area of quantum computing, and he is going to discuss all these pointers today with us. And I request all of you to kindly watch this video till the end, because if you miss any point, that will lead to you for a confusion. So I request you all to listen this video till the end. Do like and share it with your friends. So not wasting your valuable time, let us discuss with our guest. Thank you, Darshan, for accepting my invitation, and so nice to have you here. Can you please introduce yourself to my audience?
Thank you, Rajesh, Dr. Rajesh. It was a pleasure having an invitation from you. I've been following your works. I've been checking out the videos and your interactions with a lot of guests, and it's beautiful that you're trying to engage with the audience and everything. So, to say how about me, I'm Darshan. I'm based out of Bangalore. 27-year-old guy who just got into quantum computing a couple of years ago. I was a computer enthusiast since my childhood itself. And, like engineering, computer science, got into tech in a very early age, started off with like seventh, eighth standard itself. So then, my final year project actually helped me get into quantum computing, uh, where we had assisted our HOD and another assistant professor with their project on steganography, like an authentication system, where I was uh, telling my trainers and professors saying, there's something coming called as quantum computing. It might disrupt whatever we are building right now. This was way back in 2019. So that is where my introduction or my first thoughts about quantum computing emerged. And yeah, 5 years later, I never thought I'd be doing something of this sort. And then I got placed during COVID, worked at Accenture as a developer and tester, but I never wanted to, sit out and just be a guy because we have work from home. For that reason, I quit Accenture and I thought, okay, let me figure out what I have to do with respect to my tech expertise, where cryptocurrencies were booming up. The whole world was talking about cryptocurrency, with their invest in blockchain technologies and stuff. Excuse me. So that is when a question raised in my mind: what is something that can break a blockchain? And the only answer on the internet was quantum. So I thought, why not master that and see where it goes? So when I started exploring quantum computing in at the late 2023, it told me that there's this huge potential there. So I started reading a lot, picking up courses from MIT X Pro. That was my first course on quantum computing. And then it led on to me pursuing a lot more different courses available online and reading a lot of journals. But I never thought I wanted to do a PhD here because my expertise was, I was just a bachelor degree holder, not a master's student. And I wanted to publish a paper. I wanted to publish my own idea. That is when I got in touch with a lot of industry experts to get endorsement on, you have to publish a paper on ARXIV, you need some endorsement on cybersecurity and everything. So when I was reaching out to people on LinkedIn is when I got connected to a lot of professors who told instead of you just publishing papers for your own being, it would be better if you can really do an industry academia PhD, where I am not going to be a regular student. I will be a registered company because I run a registered quantum research company where we consult on quantum technologies and also conduct a lot of hackathons and everything for colleges, train students. We develop protocols and tools. We are developing software products on quantum tech. So the professor suggested me apply for an industry academia PhD, which is an open position at MIT. Get in, pursue it slowly, pursue it online for a few days, be a visiting lecturer, visiting researcher, take things slowly. So I enrolled and I got approval, I got the affiliation a couple of months back. So that is me, and here I am.
Superb, Darshan. When I saw your profile, I was thinking, like after BTech, it is written as PhD. So I was having a doubt. Now it got clarified that you are doing it as a industry academia kind of collaborative work. That's superb, Darshan.
Thank you.
And in this aspect, I wanted to know some of the important pointers regarding this quantum computing. What
Sure.
inspired you to dedicate your journey towards quantum computing and innovation? You already told some of the pointers, but
Yeah. Let's deep
what do you
dive.
think is the
Yeah.
most inspirational point for you to get into this particular area?
Great. Okay, so as I saw when I got introduced to quantum computing, it was mostly like I focused primarily on cybersecurity aspect. Like, can it break a blockchain? That was my only idea when I got into quantum computing. But when I took up the MIT Xprox course online and I was introduced to linear algebra like after like 4 years, you just do it during your college days and you try to forget it. But when I redid the course and I understood how Hadamard circuits, Hadamard gates, and these poly gates, like building circuits based out of your probability theory, can solve problems to an extent that a human brain or a classical computer can fathom, really inspired me. And that is when I came across things like biomaterial synthesis, which can be used in applications of like you can discover drugs in like matter of hours. You can simulate run test cases in such a way like we were stuck in COVID. The whole world was stuck in COVID. What if we could have developed a vaccine in a confined environment in a matter of days? How many lives we could have saved? That really woke me up to pursue this field, and that is what when I got introduced to quantum computing, it was just one niche, but the possibilities of quantum computing, the way it can handle data, I thought the next generation or the next computational era is not going to be AI, ML, or classical, but it's going to be quantum computers. The reason why I'm saying is AI will exist, machine learning is going to exist, our classical computers will exist, and they will be used in every sector, and quantum computer is not going to replace that. But quantum computer and quantum computing is going to be the backbone of everything in the next computational era. From discovery of drugs to material synthesis to our cybersecurity to the way we train AI, every computational thing that we do is going to be redefined with the power of quantum computing, and that inspired me a lot. Like, I want to understand how this works. I want to be the guy in this place for the next, at least for the next 2 to 3 decades. And here I am.
Superb, Darshan. As you rightly told, coming days, definitely quantum computing will be the backbone for all these technologies. That is very good news for all the quantum computing learners. So in this aspect, how do you define the current stage of quantum computing globally? Are we in the early research phase or already seeing real world impact?
Okay, this is a beautiful question, Doctor. I'd say because everyone has this question. Everyone I meet, maybe he's a professor with like 10 plus years of experience in quantum computing, or a new learner or a first year engineering graduate student who is keen about quantum computing, both have the same question in head. Like, are we headed in the right direction, or should I head in that path? Because it's not clear. But I'd say quantum computing is at a very hybrid phase right now. There are no existing quantum computer that can handle, let's say, a real world problem for now. But there are hybrid computers which can simulate a quantum computer's performance, the way a quantum computer does the job, and there are algorithms already ready for to be ready quantum computers. Let me put it like this.
Okay.
We have quantum computers currently, but we don't have many qubits, and there is no optimal error correction for so much of qubits. But we have algorithms ready to run on the actual quantum computers. We don't have the quantum computer ready, but there are lots of simulation softwares like environments, like our Qiskit's SDK, PennyLane, Circ. There are lots more. I guess in a couple of weeks, Quantinium is launching their own language like Qiskit. They are launching something called as Gumpy or something. So these kind of new tools, codes, languages are all introduced towards quantum computing because these are very successfully running on simulators. So if these can be actively run on a quantum computer, we will be solving problems at a very exponential scale. So we are quantum ready, but we need the quantum computer to be ready. So I'd say we are at a hybrid phase where the whole world is expecting a quantum advantage. And this is how it always is. Like how we transition from transistors to today's computers in hands. We have our cell phones in our hands that are like so much faster than our old school computers. So similarly, we are at that stage where we can develop algorithms. We don't have the qubits and the quantum computers ready, but System 2 from IBM, the Miscus satellite from China, and Japan's recent new quantum computer. Bangalore itself, they launched QPi AI launched 25 qubit quantum computer. These computers are all emerging, and in the next coming years, we will see an exponential rise in the number of qubits. For now, it's 25. Like IBM said, it is going to be 132 in the next year, but there are already companies coming up with 6,000 qubits, but it's noisy. But yes, we can optimize it, and that is what the quantum ecosystem is all about. So yeah, we are all in a very good ecosystem because we are being supported by lots of big tech industry experts who are ready to accept contribution in the field of quantum computing. So it's in a hybrid state, I would say, and it has a promising future.
Well said, Darshan. Hybrid state hopefully will convert into the actual state. Let us hope so. And
Yes.
see that, as you rightly told, all the quantum computers will be working with the most adaptable algorithms in the coming future. What industries do you believe will be disrupted first by quantum technologies?
Okay. Primarily, the whole world is working towards post-quantum cryptography because I see, as I say, because my expertise is again on cybersecurity, I'd say the whole world, before we reach quantum supremacy or quantum advantage, I'd say should and must be post-quantum ready, because our cybersecurity algorithms will will not be rendered useless, but I'd say will let's say will be in a very nimble state. It will be in a very weak state when the whole world is ready with quantum resources to attack. So for today's RSA encryption, it is really secure and you can't break it. But given if we can access a quantum computer in the next 2 to 5 years that has, let's say, 1 million qubits, which is not a long way at all. Like from going from 2 qubits to 128 qubits to 6,000 qubits, 1 million qubit is not that far away. But if 1 million qubit is achievable, the whole of internet security is rendered useless. And that is the state. So there are PQCs. A lot of companies are transitioning to something called as post-quantum cryptography, ensuring that their security frameworks are using those protocols. And yes, it is always better to be future-proof. So cybersecurity is one very, very important industry to be focused on. And because if you see large players like HSBC is actually implementing post-quantum cryptography and also financial modeling in their financial optimization tools. And there are lots of other companies and lots of early startups actually I see adapting PQC protocols. So that is one big industry that will, I would say, be disrupted at the very early stage. Then comes, let's say, drug discovery and chemical industries. We have scientists, we have tools, we have laboratories and everything. Accidents happen, it takes time to simulate. Maybe the side effects are not after a month, but maybe there are side effects after a year or two. So drug discovery and chemical industry is going to change. I'd say the simulation capability that quantum computer offers will help us to simulate and look further into the timeline and prevent side effects of drugs, simulate environment, see into the future, like a peek into the future of what this drug might do, and we can also simulate better compounds for better performance in an optimal way, not the traditional brute force method, but in a more confined environment with minimal side effects. So this will be another industry that will change. And then I'd say the whole of the world, the way it works from AI. Now we are all driven by AI. Even I can transcript this video in just a click of a button. AI, ML, all these trainings, the training of data takes so much of energy. The energy consumption for training or generating an AI like image over AI is so much, but quantum can get the job done in 1/10 of the energy requirement in 1,000 times faster way. Let's say the computational speed will be 100x and the computational energy required will be 0.1x. So that is win-win for both of everyone. So every company on AI ML building neural networks will adapt to quantum for computation in the back end. Quantum is not going to change anything in the front end, but it is going to be the strongest back-end support for every industry. There are big companies in financial markets like McKinsey and Co. and Vanguard who are adapting to financial modeling but using quantum computing because large data sets can be handled in a very effective manner using quantum computing. So primarily, I'd say cybersecurity and drug discovery and chemical engineering. Overall, every industry will be adapting to quantum computing smoothly. Yeah, the transition will be very smooth. Yeah.
Yeah, as you told, quantum computers will be the strongest backend for every industry.
Exactly.
Yes, that is a very good point. And coming to the most required point for all the current generation is the job opportunity. So where do you see the biggest job opportunities in quantum computing in the next 5 to 10 years?
Okay, so this I would say makes like I'd say okay. Let me put it this way. Uh, in early 1990s, if someone would have come to any engineering graduate and told computer science is the best stream, the mechanical, civil, electrical engineers would be like, no, no, no. We are the supporters of every industry. Computer science didn't make that big of a noise in 1990s. But once we transitioned to 1995, people were afraid. When it came to 1998, people were like, oh my God, I should have picked it up. When it came to early 2000, people were like, okay, this is paying a lot. And then some people switched, some people excelled, some people were lost. But in terms of quantum computing, it is not that case. Quantum computing is not going to change your job. It is not telling you you have to switch to computer science. It's not going to tell you to you have to switch. Even if you're a mechanical engineer, come to IT, get into some full stack FSD program, get paid. No, no, no. Quantum computing is not that. Quantum computing is going to provide job in every industry. But to use quantum computing, you have to be an expertise in that domain. I would say if you want to be a mechanical engineer, be the smartest mechanical engineer, know the fundamentals of how a HICE engine works, and try to convert that knowledge using quantum computing. Using that, if you want to be a chemist, if you want to be a chemical engineer, learn the fundamentals of how molecules work, how material synthesization works, and everything. Then adapt to quantum technology, because quantum engineers will build tools for you. They will build tools for you to adapt those technologies into your domain. Be ready and open to use quantum technologies, because it is not going to be a traditional method that will get you farther. You should have really, really good domain knowledge and be ready to use quantum technologies, so you will go a little faster and little further in your domain. That is how quantum technology is. You might not be a financial analyst in the future, but you will be a quantum financial strategist in future. You will not be a product manager. You will be a quantum business analyst. You will not be, let's say, a mechanical engineer. You will be a quantum hardware simulator. So, for every technology that exists today, you will have a prefix called as quantum powered this person, quantum powered this guy. So, quantum computing jobs are going to exist and are going to power. Like I said, how quantum will be the back end of every computational in the next decade. The quantum prefix of a person is going to determine how his job profile, how his need for the next industrial revolution is coming up. If you're quantum ready and if you have really good domain knowledge, that industry will pull you in. Let's say there is, to put it into a direct audience, I'd say, instead of just being a chemical engineer, know how to use a quantum tool, how to simulate molecules on a quantum simulator. Even if there are 10 resources with just a chemical engineering degree and you have a quantum expertise on simulating a molecule or something, you will have the highest perk and leverage to get hired. That is what I would say, and that is what the industry also prefers. So that is how it is going to be. Every job is going to exist, but every job will need something called as a quantum expertise to apply your domain knowledge. So be quantum ready is what I'm saying. Every industry and every job is going to stay the same.
Darshan, you have beautifully explained this scenario. Here I have a question.
Sure.
Say, for example, a chemist or a mechanical engineer, they want to add this quantum prefix to their domain.
Okay.
So let us say one guy who is just now entered into the mechanical engineering.
Okay.
So how can he add this quantum prefix to get quantum ready?
Understood. So, let's say there's this guy who knows how to use quantum, a mechanical engineer deals with what is that software, doctor? They
CAD CAM.
CAD, yeah, I lost that. Yeah. So he knows how to use CAD. Let's say he knows quantum computing, and there is a quantum tool that uses millions of data to optimize CAD in such a way he can simulate the efficiency of an ICE engine, build hybrid engines, or an automatic transmission or whatever, instead of him doing it mechanically or simulating it in a software that has limited restrictions. What if he uses quantum powered software where he will just have to increase his expertise on building quantum circuits? And no, and I would say that is at the early stage, because in the next 2 to 3 years, because we are in short of circuit designers now. But in the next 5 years, let's say there are circuit designers also available in the quantum market. This person, this mechanical engineer, should just have an idea of to understand how the circuit designer is going to solve this problem. If he gets that knowledge, if he's ready to pick up that knowledge in the span of like 3 to 6 months, getting into the tech, he will be able to understand. Depending on his intellectual, he will be able to adapt or pursue it in a in a higher state. So if he's able to implement that, he is going to revolutionize the way an engine is designed, the way a transmission system is designed. Instead of just taking the traditional route, he will be simulating greater possibilities in a confined environment so that his factory or his automobile industry or something is going to adapt to his technology. The whole team will be ready to work on his methodologies because it is far more better, far more optimized, and far more practical, and we can see the results, and we can also get a peek into the future of what problems might occur in the future in the engine also. So he will have a leverage. So that is exactly what I'm saying. So if you're a computer science engineer or a mechanical engineer or a drug chemical engineer, understand one thing. If you want to do learning today, just understand how to build quantum circuits. There are lots of tools available online. Excuse me. There are lots of tools available online. Slowly start learning, and you will know how to simulate a molecule, how to design a circuit for your problem statement, how to design circuits, gates, how each gate is used. So you will have a knowledge of how quantum computing is working, how also have your domain knowledge. So if you know both, you know how to integrate. If you just know one, it is not going to be useful. Know both. Once you know both, you will easily be able to integrate both of them. And as quantum developers, we are bridging that gap. We are building tools to bridge that gap. So yeah.
Super. This is the strongest advice that Darshan has given. Know your domain knowledge and try to get the basic knowledge of quantum computing. You try to add both of them, you will have a beautiful career. So that is very good point, Darshan. You have beautifully told it. Now, how can non-technical professionals also find roles in the quantum ecosystem?
Correct, doctor. Okay. So I actually, when it comes to research, you get so bored of reading a lot of papers, and then you just want to go aside from like you just want to run away from technical aspects sometimes. That is when I got introduced to this book called Intro to. Do you see this, doctor? It's called Intro to QC Business. It's Introduction to Quantum Computing Business. I was reading through that book is when I understood, like quantum computer is not just for technical expertise or people with just technical knowledge. This is actually like some dilemma that is going on in and around the quantum space. Quantum computing is just for very technically strong people. You should have a lot of mathematical knowledge, physics knowledge. No. I'd say quantum computer has a lot more benefits also, industry also. I was giving a talk with MBA students actually. on how they can use quantum computers.
Yes.
That is how quantum as a business itself is beautiful, because as technical experts, I can build a product. I can build a product, I can build a solution. But we need MBA students, we need business analysts, we need people who can sell it beautifully, who can productize it beautifully, who will understand what the world wants and convey it to us technical experts to build products for the society. And they will be the next generation of business managers or entrepreneurs. They will be the diplomats of our nation, who will tell the nation what they have to build, what the nation has to build in order to solve problems for the whole world, solve problems for the nation. It cannot, a technical person like me, he will come up, he'll have a small business idea. I will think, okay, this is the $1 million idea, I will turn it into a business. No, 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 no. A quantum powered MBA aspirant who understands how a quantum technology works, he will come to me, a technical person, and he will tell, use this methodology to solve this problem in such a way. Only then you can productize it and sell it to the world. We need more people with not just MBA knowledge, but also a bit of quantum knowledge and a approach towards quantum. Only those people can bring it out beautifully to the world. And the whole world is working towards quantum. So, non-technical, there are things like QC businesses, like for MBA aspirants who can get into business development, who can be quantum business analysts. And we can also say they'll be the future product managers of quantum products. And I would say HRs actually can use quantum computing for sentiment analysis. Let's say there are lots of unsaid problems and words that we cannot speak that is happening in the stress. See, people say they are in a lot of stress. People say they want to do something to themselves, harm other people. But let's say if we can, if an HR can detect his emotion just by understanding his cursor movements. Like we know that corporates might track your laptop, everything. Sometimes when you are in stress, your hand shivers and all this stuff. What if HRs can monitor that and help every employee make sure that they are in the best mood possible? Get help with our, let's say, with our classical computational capabilities. We cannot track so much of data. But when it comes to HRs who can support us emotionally, but how about them being our guardians without our knowledge in the back end? Problems that we cannot speak out, but they track us like a mom. She sees us and she knows that we are in trouble and she reaches out to us. So that kind of jobs and that kind of beautiful scenes can happen using quantum technology. So it's not just technical, it is going to be useful in a lot of other domains.
Superb, Darshan.
Yeah.
That is very nice. And here, what advice would you give to young entrepreneurs who want to start quantum focused startups? Because in our country there is a lot of motivation for establishing startups.
Yeah.
So, what is your advice to start new kind of startups in this particular aspect?
Beautiful, beautiful question, Doctor. The reason why I am sitting here, the reason why there is so much of investment happening here in India is all because of such questions only. The most used name in the quantum ecosystem here in India is National Quantum Mission, a cell in IIT Kanpur. It's a beautiful establishment, and the center just offers a lot of solutions, lot of help, and lot of support to startups across India. And under NQM, the central government has funded almost $1 billion for quantum investments. Like 6,000 crores was approved in early 2025. And not just our central government, but state governments like Andhra Pradesh, where they're setting up Amaravati Quantum Valley. And Bangalore is again on a race to set up a national Karnataka Quantum Mission. They are setting up something called a Q City in Bangalore. It's a 6.5 acres of startup ecosystem again. And let's say the government initiatives and the support for quantum startup is really good because there are two things here. One is political advantage that this government is supporting the startup. Keeping that aside, as state governments, there is this news spreading that says every state in India wants to be the next $1 trillion state. So
Yes.
they see quantum as a very good solution because quantum has so much of potential. So this kind of help is being offered by central and state governments. But coming back to your question that says how to, I would again say, I would again go back to my first say that I say have domain expertise. If you are really, really, really strong about in your domain, and if you can just pick up a little bit of quantum knowledge, you will know where to use quantum. So, and then choose your solution. Once you choose your solution, build a quantum powered solution for that problem statement, and people will support you. If you don't have a domain knowledge, it is hard because quantum will literally change everything and you will get lost. So, if you have a domain expertise, focus on that and build a company out of it. So, I would again say for young entrepreneurs, get into quantum. There are lots of trainings and lots of courses and lots of resources available and lots of support systems. At the same time, domain knowledge again, because if you don't have domain knowledge, you will not have an idea of where to use quantum at all. So stick to your domain, get expertise. If you're doing an electrical engineering, if you're doing electronics and communication, I'd say, for example, I'm saying, if you're an electronics students, focus on semiconductors, just semiconductors, because the semiconductors that you are going to synthesize today is going to be the backbone of the quantum computer of tomorrow. Maybe you can come up with photonic, neutral atom. Now IISc Bangalore has developed something called as carbon graphene nanotubes. So there is lots happening in the space, but we cannot expect anything new or anything productive from anyone without a domain knowledge. So only people with really good domain knowledge are excelling in this field. So build that as entrepreneurs. Believe that quantum will change the world for good, and make sure that you have the domain knowledge to change the world. That is like the biggest advice I can give. And I have met a lot of experts on this field. Even they told me the same thing. They are like, power it with quantum is what they are saying. You have a beautiful knowledge in this field, power it with quantum. So that is the most beautiful aspect. You need not change your ideas or interest. You just have to fall in love with your interest so much and push it into quantum field and then make it huge. That's it.
Well said, Darshan. That is 100% true. And I think universities and all should revise the curriculum as well, so that this quantum flavor gets added to every course.
Exactly.
So if these kind of initiations are done, definitely all the students will get motivated. As you rightly told, triple students, ECE students, mechanical students, they should be given some flavor of quantum computing in the syllabus itself, so that they will start thinking in that direction. You have told an excellent point, and that should happen really for the students to have a lot of job market in the coming days. That is what I really want for the young generation, as you rightly told. Now, if you see, how do you see India's...
I have a small point to add. Sorry. I'm really sorry. I have a very small point to add. At Aion-IA, we are actually conducting hackathons. We are actually doing a non-profit training program here from Bangalore. We are setting up Center of Excellences in colleges. We are signing MOUs to support research, to train students on every domain, to set up hackathons in colleges in quantum computing. Everything as a non-profit. Just because we want a lot of people into the quantum ecosystem, contributors. So we are in talks with big players like IBM, I am also in touch with National Quantum Mission, Karnataka Quantum Mission to support growth. So there are programs and there are companies like me, us, and everyone who are helping colleges to set up grounds for quantum computing. So yeah, I would like to tell that also. If anyone is interested, we can reach out to our website and everything. And as again, doctor, like you, people who are giving a voice out to these kind of techs and ecosystem is again very useful because it's always someone who has to put a limelight on the tech and they are very important. And thank you again, doctor. That is what I wanted to mention, that there are lots of training programs that we offer. So because every college should have, in today's generation, every college should have an access to quantum computing or quantum domain to their colleges, because that will future proof the students who are graduating from that college. So yeah, I wanted to add that point.
Exactly, that's a well added point. That is 100% required, as you rightly told. And if you take the most important point, like how do you see India's role in the global quantum race? Already you have mentioned some beautiful points. And what unique opportunities exist here?
Okay. This is a beautiful point, Doctor. I love to talk about this point because the reason why I started a company out of quantum is because we, as Indians, we were all, like in the past 2 to 3 decades, we were all like, get a good, get into good college, build really good domain knowledge, go to the West, grow your career there, settle there. That is the idea. Because in the global market, there's always a saying that says Indians are cheap labor. You pay them less and you get a lot of work done. And we are really good at technical expertise. Our education system is really has a really good base. So I'd say this generation and this opportunity of quantum market, I really wanted to start it as a business because I see India's potential here to multifold in future. I see we need not be following the West here. We can lead the world here. We can lead the world. That is what I'm saying. Instead of just looking up to their technologies and adapting, not to pry on others' success, but I would say we see a lot of delivery apps. We see a lot of, let's say, commuting apps that are existing today. Was it born here in India? No. It was an idea existing in West, which we just copy pasted here. Nothing new tech, but we'll proudly say we adapted, we are giving job opportunities to so and so people. Yes, we need all that, but we were always looking up to the West. But here I see the whole government and the whole country is ready to support our ecosystem, quantum ecosystem. And maybe this era is, and this coming 2 to 3 decades is our opportunity to lead the world, because we have such amazing talent pool here in India that we have to use and lead the world. So much, so a large opportunity in the world market. So yes, so I'd say for India, it is the golden period. For India, it is the best place to be, and we are at the right place at the right time. We just have to use this opportunity to grow as a country. And yes, not keeping aside, we have to lead as a country alone. We have to collaborate with different minds. We have to do it for humanity, explore space. Maybe we have done a lot here in this planet. Maybe space exploration might start when all countries come together, because quantum powered solution to explore space might be our next big adventure trip out of our civilization. So yeah, that is how I see quantum opportunity in India and for the whole world.
So, yes. And if you see, there are so many misconceptions among the people about any technology that comes. In the same way, what do you think is the biggest myth or misconception in the people about quantum computing.
Okay. Okay. The first thing I would say is everyone thinks quantum computing is, again, I told this point, I guess, like they tell this is for people who are into physics. You should have
Yes.
like high knowledge of physics, only then you can get into quantum computing. No, 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 no. Quantum computing is not quantum mechanics. Yes, I would say it's for physicists. Even us computer scientists go hands down. No, 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 no. But quantum computing and quantum opportunity here is for everyone. So
Yes.
it's not just for theoretical physicists or physicists alone. At the same time, you need a good mathematical knowledge to be a technical person in quantum. You need not have a mathematical knowledge when you want to be a business person. When you want to be a financial strategist, you should know how the market runs. You should know how you should be a good BCom student. You should not be a BTech student when it comes to financial optimization. You should be a BCom student who knows how to use a computer.
Yes.
So that is what I'm saying. So these are the myths that say you have to have PhD to pursue quantum computing. You have to have at least like you have to have like proper research knowledge to pursue well on quantum computing. No, no, no. This is absurd. Like because this is running in a lot of young people's mind. Like there are undergraduates messaging me, asking on LinkedIn, saying, "Oh, sir, I don't have so much of knowledge on physics and all. Can I get it?" I always say, start off. Everyone has to start off at some point. But pick a stream. Before you pick a stream, make sure you know what you want to do in life. Once you're clear there, quantum will help you get there. Using quantum as a backend, pick your stream and move forward. So you need not have that doctorate, you need not have PhD, you need not have a very strong mathematical knowledge or physics knowledge. But if you are very strong in your domain, quantum will help you to move forward. Yes, this is one of the biggest myths that I want to break here.
Yeah, you addressed the biggest myth, Darshan, that physics is the backbone, and most of the people drop there itself. You have addressed it, so thanks for that. And finally, Darshan, what message would you like to give to the next generation who want to be part of this quantum revolution?
Okay. Okay, doctor. So this is like I'd say I'll interrupt the audience. Like, get in, get in. We are welcoming you to come into quantum computing ecosystem. There, we see a large potential here, and everything that you see here is new. It is going to be interesting. It's going to be new. The way you solve a problem is new. Everything is going to be a new approach, and it is very promising. And I'd say you are seeing the world in a classical computational manner, but let's say to put it in sci-fi movie terms, there is possibility for time travel. I will not say really like sci-fi movie kind of time travel, but theoretical time travel is possible here. And let's say material synthesis, we would have seen 3D printing, we would have seen they are printing. 3D printing is now possible, but how about us printing human organs? Let's say someone gets amputated, and instead of having a bionic metallic hand, what if we can build system to regenerate his hand? What if that kind of computational possibilities is possible in the upcoming decades using quantum computing? So these are all very interesting. So quantum computing is very interesting. So I would heartily welcome every interested student to come into quantum computing with their domain knowledge, because we don't want to confine them saying this is the domain knowledge that we require. You can have any knowledge, but be an expert there. Once you are an expert there, come here. We will tell you and we will teach you how to adapt quantum technologies and then provide solutions for the world. And that is the whole mission, that is the ground mission, the whole community of quantum computing is here in India and the world again.
Superb, Darshan. You have nicely told all the points, and hopefully, if the people listen to this podcast from beginning to ending, they will definitely get the best knowledge that you have provided. Thank you so much for that. And what you told is the wonderful point. I want to again highlight that is that learn your domain knowledge perfectly and then come to quantum computing. Definitely you will shine. That is an assurance for all in the coming generation to take up this quantum computing and shine and prosper. On this positive note, thank you so much for spending your valuable time and giving us beautiful points. Thank you, Darshan.
Thank you, Doctor. Thank you again for this opportunity to talk, because a lot of things like this should happen in the quantum space. And people like you, people like Dr. Rajesh, I would say, like, these people actually bring out the love for getting to people know what is really happening around in the world. So thank you again for your time, Doctor. Thank you for having me in your podcast. Wishing you success. Maybe we can collaborate in the future. I want a lot of your audience to be inspired from the videos that you make. I want all of them to at least make a difference watching this video. And this is an open invitation from my end. Please get into quantum computing. We are very welcoming.
Superb, Darshan.
Yeah.
Definitely
Thank
it
you.
will happen. Thank you so much.
Thank
Wish
you.
you all the best. Thank you.
Thank you, Doctor. Wishing you the same. Thank you for this good conversation. Good day.
Thank you.